So our exponential and logarithmic functions are a couple new graphs that we're going to see. We're going to spend more time in sections 2, 3, and 4 kind of looking at those graphs. To start, we're going to be dealing with the algebra functions and composite functions. We also, you'll see these referred to as function composition and function combination. Okay, two things. Function composition and function combination are the two things we're going to be working on today. We're going to start with function combination, and that's when we're doing operations on functions. We are adding, we are subtracting, we are multiplying, we are dividing. We've been doing that with polynomials for months. We're just changing the notation of how it's written. That's all we're doing. We're changing the notation of how it's written, and then we're applying those operations. So what's going to be new is seeing these four different notations. F plus g of x, f minus g of x, f times g of x, and f divided by g of x. So we're changing the way that it's written, but all we're doing is we're taking two functions and adding them, or two functions subtracting them, multiplying them, or dividing them. Okay? We're applying those operations. A lot of times what we're going to be dealing with is polynomials. We've been adding polynomials, combining like terms. We've been subtracting polynomials. We've been multiplying. We've been dividing. We're just changing the notation. Okay? So whenever you see something like f plus g of x, just remember that you can write it separately as f of x plus g of x. And then we can substitute in the polynomials, and then we can evaluate and simplify. With product, sometimes you'll see it with the dot. Sometimes you'll see it without a dot. It still means multiplication, f times g of x. Just like when I have x times y, I'm multiplying those together. I don't need the dot to show that I'm multiplying them. But I'm going to preview it now. There's another symbol that's similar to that. That means something completely different. And we're going to see that in a few minutes when we do composition. So it's just a matter of rewriting it, plugging it in, and simplifying it. So I'm going to start with f plus g of x. F plus g of x is f of x plus g of x. We can write it separately. F of x plus g of x. And then we look in our problem and see, well, f of x equals 4x plus 3. So I'm going to replace f of x with 4x plus 3. And then I'm going to take g of x and I'm going to replace it with x squared. So I'm just going to split them, write them together, and then I have to ask myself, can I combine like terms? Do I have any like terms for this? No. Okay. If you do, then you'll just combine them. Okay. If you have 4x and 3x, add them together. If you have 7x. If you don't, then let's just write it in standard form and be done with it. X squared plus 4x plus 3. That is f plus g of x.
Wait, so you wouldn't put a negative when you switch it?
I'm not moving it from one side of an equal sign to another. I'm just using commutative property to rearrange it.
Okay.
Now, subtraction. Got to be a little more careful because we're subtracting one function from another. So I have f of x minus g of x. So I still take f of x, 4x plus 3, minus g of x is x squared. Do I have any like terms? Still no. So I can go write it in standard form, but since now x squared is negative, it becomes negative x squared plus 4x plus 3. Now I want to add a note in here. Let me add an example B.1, okay, or B.2. Let's change g of x to be something like x squared minus 2. Okay, let's add in a second term there because I just want to make a note about subtraction. If I do the same thing, 4x plus 3 minus x squared minus 2, both of those terms are being subtracted. So don't forget to apply that subtraction to both of those before you combine like terms. So this would then be 4x plus 3 minus x squared. And when I subtract a negative, what happens? It becomes positive. So don't forget with subtraction that you're going to have that sign switch because you're subtracting everything from that function. And then we would combine like terms to get negative x squared plus 4x plus 5. F times g of x. We're multiplying them. F of x times g of x. What do I do when I'm multiplying polynomials?
Distribute.
Yep, we're going to use distributive property. So x squared times 4x gives me what?
4x is 3.
Good. And x squared times 3?
3x times 3.
3x squared. And then f divided by g of x. F of x divided by g of x. 4x plus 3 divided by x squared. Now, most of the time, that's probably going to be fine. Okay, we can leave it at that. Sometimes we may need to simplify it a little bit more. If you have 2 terms in the denominator, leave it. But I have 1, so I technically could simplify this a little bit more by writing it as a division by a monomial. I can take the term in the denominator and use it as separate fractions because I can simplify the one on the left. If I have 4x over x squared, how is that going to simplify?
Or you can't.
I can. I have a common factor in the numerator and denominator. What's the common factor? X. So cancel out the x. And then the one on the right, I can't simplify at all. So probably this is going to be fine. But if it says, hey, you need to simplify it, that's what you got to do. Okay, so just keep an eye out for that. Those are the same thing. Okay. All right, so that's our function combination. Adding, subtracting, multiplying, dividing, simplifying as much as we can where we can. So now we're going to move into composition. And composition is going to be a little bit different. First thing I want you to note is how the symbol is different. It's an open circle. A lot of times that gets confused with multiplication. Don't confuse it with multiplication. It is a different operation. It is composition, where one function becomes an input into another function. I would take all of g of x, whatever g of x is, and I would take that and put that in to f of x. Okay, and that would be my input. Now, if I know the value of x, then it becomes just a matter of I evaluate g of x first, get a new number, and then plug that one into f of x. If I don't know what x is, then we have to literally put one equation into the other and simplify it where we can. So we're going to be given the value of x first for these. So I have f of g of 2. I usually like to rewrite it in the notation without the composition symbol and with the parentheses because it just makes it a little bit easier to kind of remember the order of things that we're doing. So take f of g of x and write it as f, and then in parentheses, g of x, or g of 2. And so if we think about our order of operations, we always do parentheses first, so we need to work from the inside out. So what we have to do is we need to figure out what g of 2 is. So we need to evaluate g of 2. So take g of x and solve for g of 2. If I know that x equals 2, what am I going to do with that 2 in my equation?
We'll put it in the 2x.
Yeah. 2 parentheses 2. Oh wait, sorry. 2 square root plus 1.
Squared plus 1. Yeah, we're going to substitute it in for x. So 2 squared plus 1. What is 2 squared plus 1? 5. So g of 2 equals 5. So now that I know that g of 2 equals 5, I can replace it in there and now change it to f of 5. So I evaluated g of 2, got a new solution, and now that becomes my new input into my first function, f of x. So now I need to solve for f of 5. Substitute x with 5.
That would be 5.
It'd be 5 again. So f of g of 2 equals 5. Now the order matters. It's not commutative, because if I switch it to be g of f of 2, even though I'm using the same x value, it's not always going to be the same solution. Most of the time it's not going to be the same solution, because we're evaluating it in a different order. So we're still going to take it and write it as this new notation, g of f of 2, but now I need to evaluate f of 2 first instead of g of 2. The first one I did g of 2. Now I'm going to do f of 2. So f of 2, 2 times 2 minus 5 equals what? -1. Now, -1 is now my new input into g of x. So g of -1. I'm taking that and I'm replacing f of 2 with -1. And I can solve for g of -1. -1 squared plus 1. What's -1 squared?
1.
And then add 1 to get 2. So g of f of 2 equals 2.
What about the -1?
I already used it. The only thing we had the -1 for is to replace f of 2 and then evaluate again in order to get 2. This isn't part of my answer, and this isn't part of my answer. It's part of what's used to get to the answer.
Okay.
We evaluated one function first, got that number, plugged it back into the second function, and then finished evaluating.
Okay.
Now, I'm not always going to be given the value of x. We're just going to be given the equations, and we still need to compose them into each other. So then it just becomes a matter of kind of putting one in and then writing and simplifying. So same idea, f of g of x. But now you can see again that g of x is my input. I don't know what x is. It can be anything, and it is everything. But I know that g of x equals x squared. So I take this function, x squared, and it becomes my input into f of x. It's my new input, so I replace x with the entire other function, which happens to be x squared. So f of x squared, g of x is x squared, so I have f of x squared. I replace g of x with x squared. And then I just take this and I plug it into my new function. F of x is 4x plus 3, so f of x squared is 4x squared plus 3. I replace one function into the other. When we change the order, again, it's going to make a difference, just like it did on the last side. Here I have g of f of x, meaning f of x is my input. So I'm going to take f of x and 4x plus 3 is going to become my input. So g of 4x plus 3, and I'm going to replace x, not x squared, I'm replacing x with 4x plus 3. X was replaced with 4x plus 3. Nothing else about the equation changes with either of these. On the left, I still have 4 plus 3, but x became x squared. On the right, I still have squared, but x became 4x plus 3. Nothing else about the equation changes, just the value of x. The value of x changes to the other function. And so now I have that, I have that. Those are the compositions, f of g of x and g of f of x. You have to be very careful with composition. Go slow. Rewrite it and think about and process what that means. One function being the input to the other. Because it's really easy to get things switched up or to take stuff out that shouldn't be taken out. You need to be really, really careful with composition. Once you get the hang of it, it's really not that bad, but you kind of have to understand that one thing input into the other process. Okay? Questions, comments, concerns, queries, or conundrums?